Okay, so today we're working on a very exciting project, and it is installing the throttle quadrants and the gear selector. So we have the throttle, actually the pilot's throttle quadrant here, and we have the co-pilot's over in the shelf we're going to be bringing out today and installing. The front and the rear throttle quadrants are going to be connected with some threaded rods so they control in unison to each other. And basically we have to install the interior skins first. Then we can install the throttle quadrants, hook them up together, and then we can go to installing the gear selector switch that we have over here. And this will all be on the left side. So we're only gonna be installing the left side interior skins because that's where all these controls are hooked up to. We're gonna leave the right side open just so we can get to some of the rest of the installation on the interior a little bit easier. So we're gonna get these installed, and then we will be one step closer to getting this Mustang up and running.
So this piece gets riveted onto the backing plate, which is welded onto the frame, and when this is all riveted in, then we can reassemble. You attach this and then we can reassemble the throttles when they're in place. And that makes a lot of sense, makes it maintainable afterwards, and keeps it from rocking back and forth. Okay, get Jake back to work inside.
Okay, as you can see back here, we have the holes drilled where our throttle quadrant will be. So this is the throttle quadrant bracket, and we have the mounting holes drilled. We're only going to use these holes right here. And what we found is that we have a little less than 1/8 of an inch space in between the skin and the bracket that we want to mount this throttle quadrant to. And what we ended up doing is making this aluminum spacer. This is going to sit in between the green steel bracket and the skin. So this is going to go in between the skin and the steel bracket, and then this is going to go over the skin, and it's going to sandwich. It's going to be 4 pieces that are going to all sandwich together. So we'll prime this stuff, put it in. As you can see, there's a big hole on the bottom, and there's one in the back as well, and that is because throttle quadrant is basically centered and mounted onto this AN4 bolt, and it's welded in the back, and because that sticks out, we need a hole in the skin so this can slip through and sit nice and flush. You're not going to see it in the plane. So once this whole thing is mounted, all the holes and everything's covered up. So we're going to put this on, we're going to rivet the holes to the bracket, we're going to rivet the inside skins, and then the throttle quadrant should be ready to reassemble, attach together, and then we can move on to the gear.
As we work on the throttles, one of the features that we want to implement here is a safety switch, so that when you retard the throttle to a certain point, if the gear is up, you will get a gear warning. And this is something that Titan includes with their kits, and it's also a feature that you'll find on most general aviation retractable aircraft. And one of the things that I wanted to do when setting this up is make it adjustable in a way that it can come on at reduced throttle settings, but not where you have to be all the way back to idle. And that can be a little bit difficult to get set if you're just going to take something like this micro switch here, which just clicks at one point, and you want to use a throttle that's going to hit a point but then continue to go beyond that as you retard the throttle. So that the way that the Bonanza does it is kind of interesting. It actually mounts the throttle switch on the lever arm so that actually it gets clicked as a part of the arm, the shaft that is, that controls the throttle, moves through and then stays up at that point as you continue to move past. That's kind of hard to understand, I think, but what I'm trying to describe is that you have a rod and you basically have a point in the rod that bumps up and then continues so that your throttle gets hit and then you can continue to ride on that point. So how to do that? Well, we have these rods, and I'll grab one of them right here. We have these rods that go fore and aft along with the throttle as it moves. And it just so happens that the diameter of that works for this tubing that I have, which the rod can go right through the tubing. So what I'm going to experiment with here, and I think it might work, is to go and take a piece of this tubing, to cut it off, smooth it out, and then also I'm even going to put it in a drill chuck and see if I can kind of put a ramp on it a little bit. I don't have the metalworking tools to actually put it in a metal lathe, which is what it needs, but I'll experiment and see what I can do and see if I can create a little thing with a set screw that I can then locate wherever I want to very easily on that rod. Click that micro switch and then it will set off the alert if your gear is up beyond a certain point of retarding the throttle. So let's try that out. Well, I'm excited to say that the idea actually works. And before everything gets put back together here once and for all and the throttle quadrant gets all assembled, I wanted to show you what is actually been done here. So the micro switch here is on a bracket that I made. Very simple. It's got a little cover in front. And what happens here is that I can adjust the position of this aluminum piece that I made out of the tubing, and that is what triggers the micro switch. So all I need to do here, in this case, I've set it to one position, and you can see as the throttle comes back, it gets to a certain point, clicks the micro switch, and then you can go further back from that point. And the point at which the micro switch gets triggered is something that I can really easily adjust from the cockpit using that small set screw. So it's in place here, it's been tested. This is the rod that goes back to the rear throttle, so they move in unison. It's adjusted here, and again, the nice part is I can adjust that position that gets triggered. That will then look to see, is your gear down or is it up, and it will alert me on the panel and also through a gear warning horn. So that's it. It's all working in place. Time to put all this back together and get the entire left side closed out, and then I'll be able to move from here to mounting the gear lever as well, and this whole section will get blocked off. It's a little scary not having access from this point forward, but fortunately we set it up so that I'll have access from the right side to work on everything until we completely close out the fuselage, at which point it's going to be time to move it out of our house, out of our living room and dining room here. Let's talk about the landing gear lever now on the Titan T-51D Mustang. This is it, and it is, in my opinion, a very eloquent piece of engineering. I really like the way that this thing works. So I'm going to take the cover off and show you what's inside. So the way that the gear lever works, it really serves two functions. One of them is essentially an electrical function to tell the hydraulic pump to run the gear up or run the gear down, which is just telling it to go in forward or telling it to go in reverse. And that's done by these two micro switches, which are engaged in the down position, which this one is in right now, and the up position where it goes here into this point. But it does a second function as well, and that's what you see from these cables. These two cables actually are hooked here to the actual lever itself, and they serve a function of releasing the down locks. You have these down locks which grab the main landing gear and hold it in position. You can't raise the gear unless you release the down locks. And so the nice part about that is by having these two positions, what happens is right now we have the landing gear down switch engaged, and the down locks, which are spring loaded on their own, are by default engaged. So we assume the landing gear is down, we've run it to its completion, and it's clicked into those spring loaded down locks. Now I move this out of its little stop here, I pull it up, and what it does is it starts pulling these cables. As it pulls these cables up, what happens is midway through, we haven't yet started to engage the gear up motor. So right now, nothing's engaged, no gear down switch, no gear up switch, but we've pulled on these cables and pulled those gear locks away from their spring-loaded position, locking everything in place, and now the gear is free to move. We bring it all the way to the top, click, that happens the top micro switch, we start running the gear up, and then the rest of the gear cycle happens until it actually gets into position. And then when the micro switch is hit that the gear is now up, the pump stops, everything stops. So very, very cool and safe mechanism, and I think it makes for a really good aircraft. So now I'm just going to get this installed. Well, that's it for another cool stage of building on our Titan T-51D Mustang. I love it when controls go in. It just makes it that much more real that we're going to have this airplane in the air, and it probably won't be that long from now. The fuselage is so much of the work, and we are just wrapping things up quickly here with all of the systems. And so everything we tried worked, which is really fun. We've got the controls working in tandem here for the throttle. You can see both the forward and the aft throttle working. Have to put the control in still for the prop to have that in there. I love the design that Titan has for this throttle quadrant. You can just easily adjust by twisting this right here for the friction setting. We've got our alert and our warning, and down here, which you can just barely see in the picture, our gear switch. That's all mounted, ready to go. And the rest of that will go in when we put it on the center section. Until next time, I'm Jeff Simon for SocialFlight. Be sure to check out SocialFlight.com and the free SocialFlight mobile apps for Apple and Android devices. We have tens of thousands of aviation events and destinations, so many cool places to fly, and our Fly to Win challenge as well, where you can win prizes. It is so amazing. We just gave away an Aspen E5 electronic flight instrument worth $6,000. So cool. And so be sure to check all of that out and subscribe to our channel. Until next time, I wish you all blue skies.